All right, welcome to another video. This time we are dedicated our time and energy to mathematics, specifically discrete mathematics. I'm going to start a timer, and the goal here is to be as consistent as we can with time. And we're going to put in 30 minutes here. It might take a little bit longer because of the particular goals I have in mind. But I figure we'll continue working on the same problem that we did before and try to finish it and like fully solve it. I know that we got the first half of it correct, but I think the second half of it was incorrect. But basically, when it comes to using the logical equivalence, P or Q is equivalent to not P, not P, or is equivalent to not P and not Q. So um, so here was the solution for A, and I have a conversation that we had with ChatGPT where we're using ChatGPT to verify if our answers were right or wrong. So let's see here. I kind of want to review the first statement. Just double check, make sure everything is lined up. So yes, your first expression is correct and equivalent. So let's see here. So yeah, basically here's the original statement. Is A, if A then R, if and only if B then R equivalent to this giant statement here, which basically says, I could try to read it in English, but it says not A or R, or not B or R, and not B or R, or not A or R, equivalent to this. Yeah. So that's the first one. And here's what I have in my notes, which is basically what we wrote. And according to ChatGPT, this it exactly matches your first expression. So we got that first part right. Now notice how they're using mathematical symbols, but the symbols that we're using are basically symbols that can be used in computer science. I could also replace the nots with exclamation points. And actually, I kind of want to do that just so that we kind of emphasize the idea that mathematics and computer science overlap when it comes to the language of logic, but the syntaxes that they use are different. So the syntax I have here is technically a computer science syntax. The syntax that ChatGPT uses is the mathematical syntax. Now for this next part, which is where things got really messy, and I kind of want to do it all over again. Because we just, I mean, this is just kind of frankly overwhelming. So I don't know what to do with this. I kind of want to highlight it, or maybe comment it out. If can I comment this out? No, I'm not actually working with a integrated IDE, which integrated developer environment, I believe. Computer science tool like VS Code, or I could use Cursor, which is really cool. But I guess what it will do is just create some space and just try to start all over. So here's the statement, and now the idea is to do the substitution. Basically do the substitution, and I kind of already have the idea set in motion here, which is suggesting that P suggesting that basically P equals to not A or not B, and Q equals R. It's the idea. So like I can copy all of this, and for example, I can replace not, let's see. There's definitely a more efficient way to do this. I can get rid of this statement, and basically replace it with, we'll make sure that we're staying consistent with the syntax, like so. So what we're gonna do? We're gonna do. Oh my gosh, this is gonna get so messy. I kind of don't want to do it all over again, quite frankly, because of how messy it is. I mean, looking at what we did, I mean, we did have a final solution. This is what we ended up with, and apparently it's not equivalent. Problem 2, the verdict not equivalent to your second expression. And I think the solution, maybe before actually doing all the legwork, notice that here they have not statements. And the idea is to get rid of the not statements and to only use and statements. So the presumption here is that ChatGPT is not even doing the request that we wanted. So what is the equivalent expression for this, where we only have this and this being used, and not using the or logical operator, and not using the or logical operator, pretty much using the or logical operator, the if then logical operator, and operators. So let's see what ChatGPT is able to cook up for us. So the first implication is this, and I think it has double not here. I don't know if that's right, but presumably that's exactly what we did in the first part. Here, and that looks the same to me. The only problem is that I think there's a typo here. I guess the double knots would cancel out. I think this is wrong. This statement here, I believe, is wrong, actually. I think ChatGPT made a mistake. Okay, well, here is... Oh, okay, here's the full expression using only and statements. Huh, so it's actually a more simplified response than what we had. I think the ands do cancel out. So, solution to part B simplified again. I highly recommend you watch the previous video if you want to understand what I'm getting at right now. But the idea is to simplify this expression as much as possible. So for example, I think this not is going to simplify with that not. And then same thing over here. Boom. It's not the same, unfortunately, because I have a not A over here. And then over here, this not simplifies with this not. Cancels out with that not. Right. And so I have a not A or not R, and not and B or R, as well as an and not B or R and a or R. Here, on the other hand, they don't have these nots. So this A should be just A. This B should just be B. And so that's what it's suggesting, which then begs the question, well, what would it look like if we tried to do the problem all over again? And that brings us back to what we were doing originally. I think this is going to be the last time that I do this video because I kind of want to move on to other concepts. You know, and I don't know, there's kind of like a part of me that wants to have that ultimate precision in mathematics, right? And it is definitely an inconvenience for sure. I think in the long term, it's quite inconvenient to focus on. So I think if I develop this equivalence a bit more, it's going to be not A or R is equivalent to not A, because not A is P, and we already have two nots before. Not A, M, and what would be not Q? Not Q would be B. Actually, no, it would be not R, excuse me. So that's pretty straightforward. Okay. So this is P, to be assured, this is P, and then it's not P, and then you have the original not. I think that's correct. I think that's correct. So if we have this statement, so that's one version. Then I can do the same thing with not B and R. It's going to be equivalent to pretty much the same thing, except instead of A, it's B. Again, not P. Again, not P is equal to not B. And I wonder if I can simplify that just right here and now. Just go ahead and simplify that right now without carrying that complication over. So this would just be A and not R. And then this would be just B and not R, like so. Okay. And then we have not B. I kind of had to look at the previous solution to make sure that we are consistent. Right here, this expression. Make sure it's consistent with what we currently have. Not A or R, then not B or R. That looks good. Over here, it's not B, correct, or R, and not oh man, we have an entire not here outside, which is actually different than what we have. So I don't really trust that statement. I think it did it incorrectly. So I can look at this statement here and verify. Not A or R, okay, not B or R, that looks good. Then not B or R, that's what we have, and or rather not A or R. And that's exactly what we have. It's exactly what we have. Okay, so that's the statement. I'm presuming that this statement is true. So with that, we can continue the modifications. And actually, we don't really need to do that. We have everything we need. I just now need to like cut and paste the change. So this is just my way of doing things. I think it's just a lot easier for me to process information. So like I can just cut and paste. Boom. And then there was a not A or R. Oh, wait a minute. Yep, that's right. Paste this in, boom. And then get this one. Boom. And then boom. Oh my gosh. we got a not. And same thing over here, right? There's a not as well. Okay. So yeah, pretty strange. I think these knots are going to cancel out though. So cancel knots, and we'll see what this looks like. I think these two knots will cancel out. Just get rid of those. And then these two knots will cancel out as well. Get rid of those. And we're finally left with this statement here. A or not R, or not B and not R. So yeah, like this statement is kind of like this statement, except it's not, pun intended. And then this one is kind of like that statement, except it's not. So okay, now what we'll do is we can now modify with these ors one more time. I wonder if we can simplify everything here. It really looks like we cannot. I don't see a way to simplify that. We're 16 minutes in, so we're about halfway on time. I think we're doing well on time. But what I'm going to do now is make pretty much start all over, except this time P and Q are going to be a bit more complex. This time P, for example, is going to be this statement here. B, or excuse me, Q rather is going to be this statement. That's one version of it. And then there's actually two sets of versions. There's two versions for each. And then R is actually going to be, oh, actually, no, excuse me. This will be our value for R, or value for Q rather. Okay, that's one version of it. Then I think I have to repeat it again. I'm gonna have to repeat it again several times, because each time is technically a little different than the previous version. So P, that's P, this is Q. Okay, that's good. And then for the next set, this is P, and this is Q. So maybe I can do like P1, Q1, P2, Q2, like so. And you can see they're similar, right? They're very similar. I kind of want to flip these values around a little bit, actually. I could do that. That might help. So we canceled flip. We're allowed to do that. We can just do a quick flip here and basically move this to the right side of the OR, and get rid of that original OR. Okay, so now our P2 value is this, and then our Q2 value is this over here. And notice how the only difference between P1 and P2 is that there's a not. The only difference between Q1 and Q2 is that there's a not as well. So there's some kind of pattern here that I'm seeing. And so now we can make the change and see what we end up with. I guess before we make the change, we got to make this or this is going to be equivalent to not our value for P, and we have not Q. It's going to be not Q, isn't it? Interesting. So it'll be not Q. Oh my God, there's so many nots here. Literally are making our mind tied up in a knot. You see what I did there? I just want to be consistent with the parentheses here. So that's good. Then we got two parentheses here. That kind of creates a unit. Okay. And then I can do one more equivalence, and I'm just going to simplify the knot a bit. I'm going to simplify these two knots because I think they cancel out. And now we end up with a not A or not R and a B or not R. Okay, so that's that. And then now we will do the same thing again, except this time with P2 and Q2. And set up the equivalent of that. It's going to be not parentheses not this value here, and then it's going to be not this value here. And now we can do a further simplification. And these two knots are going to cancel out, so I'm going to copy all this and put it here. These two knots are going to cancel out, basically, and we end up with that. Nice. Now, comparing this statement with this statement, are they the same? And I would say they are not the same. They're still not the same. There's a slight difference here. So now we can make the change. I can replace this statement with this statement here. Boom. And then I can replace this statement with this statement here. I think that's right. I have to make sure. Replace this statement with that statement. And I think that's it right there. I'm not like 100% sure. I have a little bit of doubt right now, quite frankly. Like a significant amount of doubt here. Like, for example, what's going on here? Why is there double brackets here? I think I meant to get rid of this parentheses here. Right, these two cancel out, and so would that parentheses. Yeah, I think that's right. So over here, it'll be exclamation point, just one. And then over here, there's going to be not B. Okay, and just like that, I think we finally have our statement. I can put an enter there, and we can like literally compare, have a direct comparison to look at the structural similarity / structural difference between the two. And you can tell that there's this exclamation point, this not for the first statement here, but then there's a not for the second statement there. And I just don't know if they're the same or not. Now, according to ChatGPT, what they have is this statement, this expression here. So I can write ChatGPT's expression, and I can write it out. It's similar, but it's not the same. They have not. I guess I can get rid of these parentheses here. No, I want to keep those. I want to keep those. So what they have, which is fundamentally different than what we have, they have a not on the outside here, but then they get rid of these. Oh my goodness, wait a minute. Wait a minute, we don't need these parentheses. I think it should be like that. Yeah, we can get rid of these outside parentheses. Really, we're definitely trying our hardest here to not confuse ourselves. But it looks like both this statement and this statement both have not on the outside, but yeah, the exclamation point here, the second not is what changes. So yeah, I think I see the difference now. Yeah, and they just have it repeat twice. They have this statement repeat over here. That's all they have. And there's no internal not. They don't have a second layer of not, which is a bit concerning, frankly. Now, I do have the opportunity to verify the solution. I am using a book. I will put a link down below to purchase the book. But for copyright reasons, I cannot share the book online. And so I want to keep that to a minimum. I want to respect the work, but basically, I would really love to see the solution, to see if, if ChatGPT is right or wrong. For all I know, it could be wrong. I'm pretty confident that what we did here is correct. I'm about like 80 to 90% confident, especially given how we followed this equivalence. We followed this equivalence formula. And notice how we have like a not A over here, but then we have a not B over here. And so the way I see it is that that's the reason why the sequence is so different. We have the not carries over. It carries over. And it cancels out. That was the idea, is that it cancels out over there. And then it cancels out over here. And then we did a flip. Just make sure everything is aligned. But then when we do it a second time, because we have a normal A, but then we got a not B. Over here we have a not A, but a, oh, what happened here? I'm reviewing the work right now. We got 2 more minutes. It's equivalent to not A. Oh, and then double not for B, right? Which cancels out the B, but not the A. And then over here, it's similar, except now it's the A that's canceling out the knots. So yeah, I'm pretty confident that what we did is correct. But the expression we have is not the same as ChatGPT's expression. And the main reason why is because we have this internal knot that we just couldn't get rid of. But it seems like they did get rid of it somehow. And I mean, the first implication might be where the problem arises. in ChatGPT's response. I mean, we do see a mistake there. So I'm leaning towards the idea that ChatGPT's response is incorrect. But let's see. I think I can pull up the problem in my phone, and I just I really want to see here if we can look at the solution. And I think for the sake of this video, I really do want to look at the solution and just kind of find some closure. So I think we'll go ahead and do that. It's going to take me a moment though, and I for the sake of editing, I think it'll be simply easier if we don't edit this video. Okay, we do have a solution. The good news is that we can look up the solution. And I think I set that up in advance. So that make sure we have a problem where we know what the solution is. Unfortunately, ChatGPT did not provide us the solution. And so now we're going to look up the solution ourselves. Okay, I see the solution here. I see the solution. They used De Morgan's law, which I know it flips some things around. So I know that much. Yeah, they really just like jump into De Morgan's law. They apply it quite a bit. But I can at least write out the solution, and we'll see what it looks like. They use the squiggly line. I think it's the same as our solution. Now they use P and Q. I use A and B. Oh man, they have another knot there. That's not good. Oh gosh. So ChatGPT. Oh, actually no. This is B. Ooh, that's a relief. Okay. I'm gonna just stick to R the way we wrote it out. So this would be actually B parentheses B. Oh, wait a minute. No, it would be parentheses A or R, not R. And this would be not B and not R. Not B and not R, or something like that. Okay. Not trying to get too caught up in the crazy syntax or semantics, I think is what it's called. And then just do a little bit of computer science organization. This is what I would do if I was programming, just like put some spaces on, really make sure that my code is presentable. Okay, just like that. That is the solution. It is the same as our solution. So I'm here to verify that ChatGPT is wrong. We found a logical statement or a logical process in which the AI got it wrong. It goes to show you folks that the AI is not the most, I believe the term is rational system. It seems to be more reasonable than rational. And to be very clear, we can ask ChatGPT the difference between reason and rationality, but what I learned is that reason apparently uses emotions in quotation marks. Reason uses emotions, which I don't even think is entirely true. But I think reason uses more contextual information. When we think about machine learning, which is another subject that I plan to dedicate to this channel because it's another very important tool to understanding data and what I call data theory, it's important to understand how it works. And the way machine learning works is that rather than following a strict language and then following the commands of that strict language, which is the original format for computer science, it flips the order around. It has strict commands that then create a specific language. Strict commands, specific language, rather than specific language, strict commands. That's my general understanding of machine learning. So it flips the order around. And so, in other words, since you're starting with strict commands first, and then the language comes later, the actual way in which information is processed is strikingly different. And basically, you're starting with data, and you're processing that data, and then you end up with the commands later on. You're basically doing some kind of pattern recognition, trying to find the common thread in the pool of patterns. And so apparently machine learning does use Bayesian models. Check out the channel for rationality as we've explored what Bayesian means. But it's a way to work with beliefs that are basically probabilistic decisions or probabilistic actions, if not decisions. And machine learning is messy. The takeaway from that is that machine learning, because of the nature of its sequence of doing events, first focusing on the specific results, then finding the commands that would correspond to said results, you are basically starting with data. And depending on the nature of the data, it can be a very mathematically messy process. And so this is a really good example of that, because right now, it would appear that the machine learning is following a rigorous mathematical sequence, but all it's doing is looking at its data sets on these logical statements, probably using textbooks, research papers, so on and so forth, information based off of the data sets that it presumably got from the internet, and then processing that data and looking for the common pattern, and then trying to mimic that pattern, trying to repeat that pattern as the final step. And so it looks like it follows a very logical sequence, but we were able to point out that this statement here looked wrong. Right, these first implications that it's saying apparently appeared to be wrong. So it's not logically sound, the results. Even if the means by which it finds the data may be logically sound, the actual results themselves are not logically sound. So I don't know if this is rationality. I would think that this is the AI striving to be rational, but being being illogical in the process. There's a lot more to unpack on that, but really cool that I was able to throw in a little bit of machine learning concepts into this. But the general takeaway is that the AI got the usage of logical operators incorrect. That's the main takeaway. And it's a humble reminder that we're working with messy data and a imperfect system to pattern recognition of that data when it comes to using AI. So ultimately, it's a tool. It's an imperfect tool, but still a very useful tool. Thank you so much for watching this video. Comments and questions down below. I really appreciate hearing from you guys and gals. If you have any specific questions as far as machine learning, as far as using AI, as far as logical operators, I think the comment section of this video is the perfect place for that. Stay tuned for more videos, of course, because we have a long journey of information to process. And I think that's going to sum up our this chapter of discrete mathematics, in that we were able to transform this original logical statement that we had into its equivalent forms. Basically, in previous videos, we were able to transform it using the OR operator, and we got a particular result for that. So basically, this is solution for B. And then I want to make sure I have the solution for A clearly identified. Here it is. We were able to convert that original statement into an equivalent statement using the OR operator, and then we were able to take it a step further and find the equivalence of the original statement now using only the AND operator, as well as NOT. Presumably both are using NOT. But it's really interesting how we were able to focus on using the AND operator for part A. For the first part, use the OR operator initially. Technically, there's an AND operator here as well. And then for the second process, use the OR operator. I think the final version would be to have a version that only has the OR operator, and I might do that as well. I think I might do that for a future video. I kind of want to do it now for the sake of time. It would be interesting. Transform this and. So I think I might save that for the next video for this, just because of time. I want to save it for the next video. But yeah, thank you so much for tuning in. I'll see you all in future videos, and we'll continue practicing our logical operators. Peace.